Okay, so to finish off this first section on differentiation, the last little bit we're going to look at is rectilinear motion. Now, this isn't in the notes, the regular notes, this is in the Alchmuti notes. So if you go into the resources section, you'll find them in there. I've just typed them up again here just to explain a few little bits to you. So basically rectilinear motion, we're looking at speed as distance divided by time. We know that acceleration is how velocity changes, and velocity is just how the position changes with time. Okay, so that's the three things we're going to look at. Now, we'll use the word velocity rather than speed because that's technically the correct word to use. And if you're doing physics, they'll certainly be using the word velocity all the time. So displacement is just the distance travelled. The velocity is the speed, as I say. So if we know what the velocity is, that is the change in the distance compared to time. So velocity is just the change in x, so how far is travelled, divided by the change in time. So it's dx by dt. So if you've got an equation which is for x in terms of t, if you take the derivative of that, what you get from that is the velocity. Then acceleration is how velocity changes over time. So as you get faster, that means your velocity is changing. So if you take the derivative of the velocity, then what you have is the acceleration. So here, if we've got velocity is x with the dot on the top, and that's just another way of saying velocity, or we can say x dashed of t, so that's a derivative of x with respect to t, or dx by dt, so it's just ways of saying the same thing. So if we know the velocity, if we take the derivative of this with respect to time, that gives us the acceleration. So acceleration is the second derivative, so it's x with a dot on top just means first derivative, that means the second derivative. So velocity is with respect to time, so v dashed of t is the derivative of the velocity, which is acceleration. Now, if we take the derivative of the velocity, we're taking the derivative of this, so it's the second derivative of that. So x double dashed of t. And that also means we're taking the derivative with respect to time of this. So we're doing it a second time. So that means it is the second derivative, so it's d2x by dt squared. So that's how we represent displacement, velocity, and acceleration. Now, there are a few questions in the notes regarding this. So you might need to zoom into a little bit. So we've got questions here which are asking us about acceleration, velocity, etc. So zoom in there. So in the first question, you get asked to do a couple of things. It asks you to begin with, where is the particle initially? Well, initially is when it hasn't moved at all. So that's when t is equal to 0. So you're going to have to place t equals 0 into your expression for the displacement. And that'll give you your answer for part A. For part B, after 4 seconds, what are the velocity and acceleration of the particle? So to find the velocity, you're going to have to take the derivative here and then sub in t is 4. And for acceleration, you're going to take the second derivative and then sub in t equals 4. So that's going to give you your answers for that one. For number 2, you've got to find the position and acceleration of a particle when it comes to rest, if its displacement is given by that. So you basically just have to take the second derivative in order to find out what their acceleration is going to be. And for part 3, you're given the expression there for displacement. So throughout the course of the various questions, you're going to have to find out, well, first of all, when observation was started, that would be t equals 0. At what time was the object stationary? Well, it's stationary when the velocity is equal to 0. So you can take the derivative and set it equal to 0 and then solve it. You can comment on the motion of the object after 5 seconds. So if you're looking at the velocity, you can sub in t is 5 to see what's happening with the velocity. You could take the second derivative for acceleration and find out what's happening there after 5 seconds. And you could also just put the value of t is 5 into x into this expression here to find out what the displacement is as 5 seconds. There's actually quite a few things you can look at for part C. And for part D, does the object ever reach a constant velocity or decelerate during the journey? Well, I'm going to let you have a wee think about that one and come back to me with your answer.